Morning. But the food can't go in the trash either, so you put it over here if you like, like between eating and later. Yeah, the video, but video. Right? Yeah. Yes. Oh, thank you very much. Yes, did we have this correction? I can get up here. Get up here. You know what third quarter? Good question. Yes. Right. At the next week? They were due last. I give you the definitive answer. Okay, I'm not sure. There she is. All right. Oh, that's the brains. I think. Oh, I move.
We go be better.
Yeah.
Exactly. And what are you going to? Yeah, correct. Did they out that? Oh, they came out yet, but when they should. So you did? Okay, then check them right.
It's so far.
Yeah, but-
See that?
Oh,
Like that, that's.
I can talk about specifics a little bit later. I started.
Oh.
The enrollment link is coming out here about.
Oh, here comes Emma. She comes. I'll go ahead and get started. Good morning, folks.
Morning.
Hope you had a good weekend. Everyone had?
Oh, it was just that.
Oh, not enough math.
No, not enough.
Yeah, I feel you.
Although I do have a 90 on every homework. Yeah.
Amazing that you happen to coincidentally get a 90. Or is that strategic?
Oh, it's strategic.
Yeah. Okay. Yay! All right. I do have to warn you that when you just get to 90% on the homework, you're missing some essential practice. But I understand.
The
Yeah,
ones
keep
that
that
you-
down.
the ones that you should skip are the ones where it's like the same problem 3 times in a row. And then it's just kind of like busy work. Those are the ones that.
That's a nice hack. I like it. Instead of mindlessly just like the first 90% and the last.
Yeah, it's not like that.
Okay, thank you. I appreciate that. This time really is a commodity, isn't it? You really have to allocate your resources appropriately. I think that's a nice tip. And sometimes those extra problems just they take too long. So if it's not helping, it makes sense because I think you still get 100% if you have 90%. So
You do, right?
yeah, you do. You get full credit, 90% or above on your assignments. Just be sure you're being
If I
mindful.
like 2 or.
That doesn't go for 10.
Okay.
You got 100%, you have to get them all right. Makes sense, doesn't it? I think so. Okay, today we're talking about equations. Yeah, specifically exponential and logarithmic equations. Hey, this first one, we're going to use a property I like to call matching it. Oh, that's not if. If a to the m equals a to the n, then are we good with that? M equals n. So if you have two exponential equations, as like two exponential expressions with the same base, then the exponents, you can just set them equal to each other. So like here, you see 2 to the 3x minus 18 minus 8 equals 16. There are other ways to do this, but my recommended way to do it is to say to yourself, hey, that 16 could be written as a power of 2. So we rewrite this as 2 to the 3x minus 8 equals 2 to the 4th power. And now we can see from here that 3x minus 8 equals 4. From here, you better not need any help solving this one. You do the rest in your head, can't you? See that x equals 4. Are we good? Should we check it? Let's check it in our mind. Let's plug that x back into the original. So we have 12 minus 8, which I think is 4 to the 4th power. We already know that's equal to 16. Yes. So B, would you please show me what the magic number is for B? 3. Don't try to make them both a power of 9 or both power of 27. So I'll give you a chance to work through this one. Check in with your neighbor when you are done or stuck.
Oh, oops,
Ready? So, Dylan, you've been chosen by destiny. How are you feeling about this? You ready? You're good? Oh, nice. Okay.
So 0.7 is 3 to the third, so then you multiply out 3, so it's 3 to 3x plus 9 equals 3, and then like 9 is 3 squared, so it's 2x minus 2, and then x 3x plus 9 equals 2x minus 2 gets you x equals -11.
We're good with that? Could have gone right from here to here? That's fine too. Because you still have the equation in your head. I know you can manipulate it 2, 3 steps at a time. Okay, please go ahead and try the rest. All the way up to F. Right, we are complete. We ready? Ready or not? Brandon, can you help us see, please?
Oh, yeah, so what I did was, so 1/16, that becomes 4 to the power of -2, times x plus 1.
Okay, so you get 4 to the,
So you get 4 to the power 2x plus 5 is equal to 4 to the power -2 x minus 2. So 2x,
like this?
Yeah.
Okay,
so that 2x plus 5 is equal to -2x minus 2, and that's equal to 5, so x is equal to -7 over 4.
x equals what over what? I'm sorry.
-7 over 4.
Are we good with that? Any questions? Okay, cool. -7 over 4, I feel like. That's something strange. Where'd that 7 come?
That
Is
would
it
work
-7?
if you have 2x and -2x you should cancel out.
Do they? They're on opposite sides.
Yeah.
I'm just wondering what happened to the 5. Did I lose something there? You have to move
Okay.
5?
Basis.
Wait, no, it's the -2x minus 2.
Oh, -2. Oh, okay. I was looking ahead there. Okay, that makes sense. Thank you very much.
Wait. I said it would be 4 to the -1.
Oh, is there a square root happening?
We wanted the square root of 16.
Well, we want to write 16 as a power of 4. So 16 is 4 squared.
Right.
1 over 4 squared is the same thing as 4 to the -2. But we're good. Brennan, nicely done. Thank you. Any questions? Okay, next one. Dun, 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 dun. D. Maybe I can't choose you yet. You didn't have enough time. But James, can you help us out with D?
Set it to a base of 7, distributed that 2 into the x minus 2, which gave me 2x minus 4.
Okay,
Equals 3/2, since I have to add the 7 to 1/2. And so find that.
so 3 halves like that? Okay,
And then I put there, 2x 11 halves, and then 2.
we're good with that? Nicely done. Thank you. Yeah, this 7 times 7, root 7, I recommend 7 times 7 to the 1/2, and then just add those exponents together. 1 plus 1/2 is 1.5, 3 halves. E. Lily.
Oh, so because e squared is raised to the power of -x, we want to multiply those. And so I got e to the power of x minus 1 equals e to the power of -2x. And then set x minus 1 equal to 2x, and then I got x equals 1/3.
Are we good with that? Thank you. Yes, Sienna.
For D, could you also set the base equal to 7?
Oh, the base equal to root 7? You could, so you would rewrite 49 as
7 to the
Root 7.
7 to the. But I would say that's non-standard, but there's nothing wrong with that. That's like really creative. I like it. Ah, okay, interesting. Yeah, I recommend integer values, but as long as they're matching, go for it. That is nice because then you get to keep that root 7 there. I'm not gonna say no. That get full credit. Thank you. Lily, do you want another one? I feel like that last one was too easy. Do you want to keep going? Okay.
So because you're multiplying the two of these, here you have to add the exponents. So I got x squared plus 72 equals 17x. And then x squared, and then set that equal to 0, so x squared plus 17x plus 78, and then I got 0
Wait,
equals
plus 17? X squared, wait, plus 72 equals 17x, right? Okay. From there, what was the next step?
0 equals x squared plus 17x plus 72.
Okay, I thought I heard something else. Minus 17x, right?
Oh yeah, sorry, minus 17x.
Okay.
And then you get x, or 0 equals x minus 9 times x minus 8, and then x equals 8 on that.
You're one of those zero first people, huh? Nothing wrong with that. Are we good with this? Two solutions? Should we check them?
No,
It's okay. It's checking is important for peace of mind, but it's essential if you're dealing with something that has a restricted domain. So exponentials don't have a restricted domain. Lily, that was great. Thank you for your double duty. Appreciate your time. Any questions? I have a question for you. Would you please discuss with your neighbor the three main properties of logarithms that we talked about last time? It's going to start with the log base a of m times n.
Yeah. Oh, the power is come.
Yeah.
Okay, who'd like to remind us what are the rules, the three basic properties of logarithms? Yes, Baron.
so there's the one where it's the two logarithms are being multiplied, or you add the,
When you say the logarithms are being multiplied, so log base a of what? Like m times log base a of n, or
what do you mean?
will you start again, please?
Yeah, so when you're multiplying them together,
Multiplying what?
log of what?
When you say multiplying them, I just want to be very specific. Log,
I don't,
well, mn, right? I think that's what you're talking about.
Right.
Okay.
that is log base a of m plus log base a of n.
Okay. Thank you. Thank you. Do you want to keep going?
Sure, and then you have log base a of m over n, and that's log base a of m minus log base a of n. And you have log a of like the m to the n power equals log base a of m times log base a.
Mhm. We're good. I'm good with the first two. First two were good. Would you please show me the gesture that I'm looking for that third one, if you know? Looking for a gesture for that third one. Specifically, take that exponent and make it the
This is like n
coefficient. Yeah,
times log base a.
be like n times log base a of m. But thank you. You're right there. So yeah, that's what we're looking for. These three basic properties of logarithms. And I know this is a new function for you, so it takes some getting used to. So when you get to example 2, after doing example 1, you might be a little bit frustrated and thinking, how are you supposed to get these bases to match? Well, you can't sometimes. It just doesn't work. But we do know that the value of x would be between what two numbers? Between 3 and 4? We're good with that? In between 3 and 4? In between. It's not between 3 and 4.
So 1 and 2.
Between 1 and 2. We know that because 4 squared would be 16. But it's like 4 to the what equals 15. It's okay. It's okay. You're just checking the rest of the class. And they failed. But so it's temporary. You okay?
Yeah, I'm good.
So how can we get an exact number? Well, we're gonna have to use our calculator, and of course, you could just change this to a logarithm, right? Log base 4 of 15 equals X. You could do that. But instead, what we're gonna do is use logarithms as a operation. What I'm gonna do is I'm just gonna take the log of both sides. Any base I choose, I'm gonna choose common log. Log of 4 to the X equals log of 15. Now, is this helpful?
Can you just do that?
That is one property. You could take the log of both sides, a single log on both sides.
Oh.
You see what I'm gonna do with that left side though?
X.
That gesture, what are we gonna do with that X? Right, the X is now X times log of 4 equals log of 15. And since my goal is to solve for X, all I have to do is divide by log of 4, Mr. Lieberman. Yep, that's right, guys. X equals log of 15 over log of 4. And if you use your calculator to figure out what that is equal to, would you please plug that into your calculator? By the way, this charger, did I tell you? It works. It's working. Is it? Okay, you can go ahead and grab it. Is it charging?
Yeah.
I see. Is it what we expected it to be? Pretty close to 2? Just under 2, like a smidge, like 1.876 or something?
1.9.
1.95, that close, huh? So if I'm looking for an exact answer, that's the one. Right, in your test, when it says an exact answer, I don't want the 1.95, whatever it is. That's any number that you give me is an approximation because that number goes on forever. That is the exact answer, but I will put in approximately.
Like accurate answer, I write log 15 over log 4.
Yes, yes. And if I'm looking for an exact answer, I want it in terms of logarithms.
Okay.
Because there is no single number that we could write easily to represent that value. So for B, do we know what numbers this is in between? Check with your neighbor. What two numbers are the two consecutive numbers of this fall between?
I'm
So show me the smaller number between this and the other number. So it's 5 point something. Is it closer to 5 or closer to 6? So maybe 5.2. Okay. Maybe. Let's use the same method, even though you could change that to logarithm, and that would be a very nice one to do. Let's take the log of both sides. Log of 10 to the X equals log of 120,000. X times log of 10 equals, what is log of 10? It's 1, so we don't even have to divide both sides by that. We're done.
wait, go back.
I can't go back. But you can see what we did. I took the log of both sides. I chose the common log. It just worked out because the base is 10 that it canceled. If it would have been like 9 to this something, it would have been a harder time to get through this. So your calculators, log of 120,000. 5.08. Okay, is that a surprise? It's nice to have an understanding of what we're going to get before the numbers just get crunched. Yes, Sienna?
X equals 12.
Exactly. Can we go right from here to here? For this problem, we could because the base is 10. So it would actually make much more sense to do that. Oh, look. They're getting more interesting. Step one. What do you think the first step is? Add 3. I'll let you do this, Ron. You can do this, I'm sure.
It's just.
Could we divide again by? Could we divide again by? Could we point six x right, but then you have to solve for one whole x. Yeah, but even that, I think it'd be easier if we got rid of the point here and then did that.
But are you adding, but you're not adding, you're just adding.
Did you get it?
Over. Big,
10 seconds. Okay, who can help us do this one? We already said we're gonna add 3, so get 40 e to the 0.6x equals to 40. We could talk through the rest.
well, we had a really tough process.
Any volunteers? Sienna, thank you. You spared us.
Thank you, what?
This is not a meeting.
That works nicely. Okay.
Log both sides. It would be. And you put the 0.6 and 0.6 x, so 0.6.
What base would you like to use when we're taking a log both sides? Because it's your choice. 10, okay. Common log is never a bad idea. Okay, so
Log, and then 0.6 is 5. So log equals log 6.
okay.
And then I divided by, so x equals log 6 over 0.6 log e, so I divided by 0.6 log e.
Do you know what log E is?
Okay.
Or 2.
Is it ln?
Well, that's log base.
Log base E. This is log base 10 of E. So if we were to type that in your calculator, you would get a number between, don't type in your calculator, but if you were to type just log of E into your calculator, discuss with your neighbor what numbers would that fall in between.
Oh, wasn't it like 2?
Yes, you're asking yourself, log of 2.7 is approximately, well, between what two numbers? Hmm. Okay, show me the two numbers that it falls between. But we know that it can't be 1 because 10 to the 1 is already 10. So it's gonna be less than 1, isn't it? Between 0 and 1. We're good with that? 10 to the 0 is 1. We're looking for 10 to the what equals 2.7. So it's gonna be a little bit more than 0. Not that that's really important. It's kind of, that's a little bit uncomfortable compared to the other ones we were doing, I think. But just keep in mind what the concept is. But yeah, Sienna, you nailed it. There we go. That's a perfectly good expression. Did you type this in your calculator by any chance?
Did X is 0.56.
0. What?
56.
Can you give me 5 decimal places, please? Do you still have them?
History 0.5632.
Anyone else get the same number? Just out of curiosity, did you use the fraction? If you did this, what you use the fraction function? Don't forget to use that. If you don't want to use it, you could just do log of 6 divided by 0.6 divided by log e, or you could do parentheses. But thank you, Sandra. That was fantastic.
If you do like log base 16 parentheses, just like 0.6 log e times log e.
Yeah, that's perfect. Yes, exactly. Thank you. As long as you're being thoughtful about what you're typing into your calculator. Did anyone do this a different way from here? We'll discuss then with your neighbor. What's another way you could do this?
What?
Anyone have an idea? Come on. It's got to be a different way. It's exponential. Anytime you have exponential, you can rewrite as logarithmic, specifically log base. Well, I'll let you discuss. How would you rewrite that as a logarithmic equation?
E of 6 equals 0.6. No. No, we.
Okay, so how do you do this? Grand for 400.
Could make it log base e of 6 equals 0.6x.
Are we good with that? And then from there, our goal is to solve for x, so all we have to do is
Divided by 0.6.
divide by 0.6. And of course, I'm going to rewrite that log base e as
ln.
ln of 6 over 0.6. Will you type that into your calculator, please?
Ten squared equals 100. You can rewrite it. And
Do you get the exact same thing? Log of 6 divided by 0.6 is 0.556324. You know where the ln button is on your calculator? Should be pretty close to log. It works out the same.
No.
Hey, but what's wrong?
Like I'm getting 2.9. Yeah.
Are you all right? Anyone else getting 2.9? Uh-oh. Well, I'm flummoxed. Then one of these is wrong. Well, it should be between 0 and 1. I said that. And log of 6 divided by 6. I'll do something wrong here. It should be the exact same thing. Well, that's crazy. Stick equals 0.6x. Well, 6. I don't know. Anyone see the error? Because it should be the same.
What's the answer to the other?
0.5.
The one that you had was 0.56324. Oh, 2.9 is what I'm hearing.
I just put parentheses around everything in our first version, and it's 2.98626.
I took them around everything.
Yeah, maybe this is wrong.
Yeah, I thought 2.9. I probably, wait, 2.9.
Oh, you got 2.9 for that one? Oh, okay.
Wait, but aren't we looking for a number between
lost.
0 and 1?
My question was different, right? My question was what is log of E? That's not part of this question. Right, so yeah, this number here is between 0 and 1, but we're dividing log of 6 by all that. So it looks like there was a little bit of a calculator error. Thank you for finding this, Hannah. So this is actually approximately
98626.
2.8626. 27, so rounding. And then that's the same thing as ln divided by 0.6. Ah, okay, we found it. Another calculator.
Wait, how did that go wrong?
I imagine that what happened is someone did log doing this times. You see how this says something different than what's intended? I imagine that's what happened.
Wait, but if you're doing multiplication and division, doesn't it not matter you were doing,
Exactly. How does the calculator do it? Left to right. So it's doing the division, it's taking that and then multiplying that by log of E instead of keeping that at the bottom of the fraction. So if there would have been some parentheses here, like you were mentioning, they'd been perfect. Right, but this was doing exactly PEMDAS. It was doing the division and then multiplication. It wasn't dividing by log of E. That's really interesting. I'm glad we did that. So my recommendation, when you can, just change it to exponential. And it seems like some of you forgot that exponential a to the b is equal to c could be rewritten as, well, log base a of c is equal to b. And this is bidirectional. So if you have a logarithmic, you can rewrite it as exponential. If you have exponential, you can write it as logarithmic. There's just one more problem, so we're going to power through that. Then after that, you can stretch or zone out. But we have one more. Oh, we have. I can give you a few minutes break. We'll start again at 46. 46. let's finish this up. Example 4, I think you could already do this. Can you make the bases the same? I guess you know what you're gonna do. Let's see if we can get through the algebra of this problem, though.
Take the log of both sides.
We should do. Um,
You know, I'm gonna go over this with you because there's too many places it can just go wrong. Next, of course, the gesture that I'd like to see is. The thing is, when you bring it down, you're gonna have to use what's important symbol? Parentheses. Extremely important. Yeah. Yeah, but what do we do next?
But the one where you can choose the bit.
There's no need to do anything like that, although that's probably something we could do. Just common logs are nice to use. Because I know if I gave you a problem that looked like this, and don't write this down. But if I gave you something like 5x minus 3 over here, I know what you would do next. The word is distribute. Well, nothing's changed except instead of nice numbers like 4 and 2, we have logarithmic numbers, right? So log of 5 is just a number, log of 4 is just a number. You can take that and distribute. So I'll give you some time to
Wait,
let's see if you do that.
that.
So like this becomes x times log of 5 minus 2 log of 5.
Oh, that's.
Yeah, it's crazy. Well, I keep saying I'm gonna let you do it, but I don't want you to go too far astray. Okay, so how are you going to solve this though? Right? This is a problem. Which x should we solve for? Well, yeah, we have to solve for the only x that's there, except there's one on each side. So what should I do if the x's are on both sides? Just move the terms around. Just like you would do in the fake problem I gave you. Do you want to move the x's to the left or to the right? Okay, Beyonce, we'll move them to the left. X log of 5 minus 2x log of 4. Do kids in 2024 know that reference, that to the left reference? You see, okay, a couple of you, press, equals 3 log of 4 plus 2 log of 5.
Sure.
Maybe that's got to be our next song of the day. Next step. What are the 4 words I'm looking for? Anybody know? We're trying to solve for x.
Divide. Lie.
Factor out the x. Right? Factor out the x. You have x in both of those terms. And then salvation is at hand. It's right there. Is that a little extreme? My bad. Oh. For you big writers, I feel bad. Are we almost done? Yeah. All we have to do now is divide. So have x is equal to 3 log of 4 plus 2 log of 5 over log 5 minus 2 log 4.
And that's like the answer.
This is the exact answer. If I want an approximation. Then you plug all that into your calculator. I'm not asking for it though. I'm asking just for the exact value of x. We take a moment to discuss any questions you have with your neighbor for that, and then see if you can move on to example 5.
Or e to the x with a log of 4x on. Or okay, log. Oh, don't do this. Oh, so this isn't like any problem. Okay.
Okay. Shall we talk about example 5?
Yeah.
But before we do that, imagine you could go back and tell your 3rd grade self that you would have an answer that looks something like this.
I would tell you, you would say, no.
Would you maybe cry in 3rd grade?
What?
Isn't it incredible that you've gotten to a place where you're getting numbers that look like that?
If you told 3rd grade, there is a answer,
Yeah, exactly. Very few numbers in your math answer.
you probably.
Good thing you can't tell your 3rd grade self. Okay, so this one. Now you could try to take the log. Maybe you're gonna don't write this down. Don't write this down, please. But maybe you're like, okay, I get it. And then you could like move this again, don't write this down. And then take the log of both sides. Of course, I have to do this in parentheses here. Let me make this log of -3. Do you see the problem with this? There are 2 big problems.
Oh, log of negative.
The log of a negative is a huge problem. Thank you. Are we good with that? Anytime you see log of a negative number, just cross out that problem saying it can't be done. But another problem is that the left side, nothing helpful is happening. There is no property log base a of m plus n. We can't do anything with a sum or a difference inside that. What's it called inside the parentheses?
Argument.
Inside the argument. So this is just not a helpful strategy. If you were to try to take the log immediately, you just have a sum of 3 things. So it's just not helpful. So what's another strategy we could use here if we taking the log of both sides isn't helpful? Any idea? Because there is a hint. And it doesn't give it to you explicitly. Yes, Sienna, you have an idea? Quadratic form. How did you know that?
X, X,
Yeah, that too, there's a huge hint. It's a quadratic form equation. So we're going to use a substitution to do this. We'll say that a is equal to e to the just x, right? This one, a is equal to that. Hopefully not. That would suck. No, you don't need quadratic formula.
If you use anything else. Over here.
getting anything? I get the sense of you finished.
Okay.
This is some really good stuff.
Yeah. we have to solve with you about it.
Did you get it? Yeah, I need a volunteer to help me with this one. Who'd like to help? Sienna for 500.
Effect.
Mhm.
Or I did a squared minus 4a plus 3 equals 0.
Okay,
And then with back to that, you get a minus 3 times a minus 1 equals 0.
oops, a minus 1. Okay,
And I got 8 equals 3 and 1.
okay,
If you put that in e of x, you get e of x equals 3 and e of x equals 1.
e of x,
Or e to the power of x.
e to the x equals 1. Okay,
And, I put that to log e, log base e times 3 equals 7.
log base e times
Or
3.
log base e of 3.
Oh, okay. And what is log base e?
Oh.
So you're saying here x equals ln of 3?
And then ln equals x.
Here x is equal to ln of 1, is that right? Okay. Is that it?
That's where I start.
Thank you, this was great. Any questions about this?
Yeah, isn't ln of 1 0?
Is this true? Ln of 1 is 0? Is that true? I remember log base anything of 1 is equal to 0. Nice. So we could simplify that to x equals 0. How about ln of 3? Would you please check in with your neighbor about what that's approximately equal to between what and what?
Oh, what? Like about. Might be more.
One and two.
Please show me the numbers between which it lies between 1 and 2. Closer to 2? Right, closer to 1, right? 2.7. So the first would be 2.7. We squared it gets closer to 9, so closer to 1. But I don't care about that. I want exact answers. So yeah, ln of 3 and 0 are what I'm looking
So if
for.
I wrote ln before, that would be wrong.
Yes, I'd take off 1 point. Thank you. That'd be like leave an answer as 5 times 0 instead of just 0. And by the way, substitution, you don't have to do it. You could just say e to the x minus 3 times e to the x minus 1 equals 0 if you wanted to. Would you be comfortable with that? It's up to you. You're more than welcome to not do the substitution. You just write it from here, and then that's the problem. Okay. Oh, and let's just check. Let's check the 0. Does it work if we plug in a 0? Yeah, 1 minus 4 plus 3. There we go. It's equal to 0. If you plug in a ln of 3, what is e to the ln of 3? What is e to that? Do we know what e to the ln of 3 is? No, we should know exactly what that is. E to the ln of 3, do we know what that is?
Three.
It's 3. Right, because this is a log base e when the bases match like that. This is just equal to 3. So I'm wondering what e to the 2 times ln of 3 is equal to. What is that? E to the. Well, what can I do with this 2 to get that out of the way?
It's 9.
It's 9. Do you see it? This is the same thing as
Yeah,
e to the
bring it
ln
back
of
up.
9. Yeah, now we can use that property. So this just says 9 minus 12. 9 minus
Oh,
12
plus 3.
plus 3 equals 0. It actually isn't too bad. It takes some getting used to, though. Okay, that's fantastic work today. You have a little bit of time to work on your assignment.